Welcome, I'm Blair, creator of SoEx and author of Method Sketch if you've been watching other videos. Today I have with me Riccardo and I'm going to be giving Riccardo a demo of SoEx. So Riccardo, why are you interested in SoEx?
So, Blair, you and I have known each other for a long time. We've worked in similar circles. We've also worked in service-oriented architectures and so forth. And we've always both been very interested in how to abstract the plumbing away from the actual architecture that you're creating. Things like the bindings, the communications, the protocols, and so forth. So when I knew that you were working on SoEx, I was very excited to learn more about it so I could actually start incorporating it into my own projects. So yeah, I'm very excited to learn as much as I can.
Yeah, so you can find it on GitHub, search for Blair Moyer and SoEx. And there's a link down here that will take you to a tutorial. So I'm going to be diving into the IDE in a moment, but everything that's in there you can get by following this tutorial, which will start with instructions on how to create the solution and things like interfaces to copy in and the content of the services that we'll be looking at. So if anyone wants to follow along, you can find it via the tutorial, and I'll also put links in the description. So to start with, we have a membership manager interface. So this is just the interface for the service that you're going to be using, and so there's nothing other than normal C# here. It's just a C# interface with an operation. We've got the manager itself. This does take a reference to something else, but again, this is something defined by this project. You can see the IFX proxy part here. If we dive down here, that exists as part of this project. So the references to SoEx are actually a step below. And then the other part that we're going to look at here, because this calls something else, is we have a user access, again with a single operation, and again with an implementation. So the only parts that I had to sort of create by hand here were these 4 files. The rest of it was all templated. Then in the program CS that's going to run, we have a call to this manager. So if we hit debug, it will run through. And so that's it, finished executing. We can come across to the logs, and then you can see that we've got some calls here. So if we show this here, we've got tracing already set up. And you can see here, if we go find this one and take a look, it says that the instance is running is in proc, which is also shown across here. And that down here, if we find this one, this is also in the same process. So what we're doing with the first example in the tutorial is showing hosting multiple services all in a single process, but isolated as if they were running independently. And so when we later on do an example of them running in separate processes, all that should happen is a change in this service name here. So before I continue, any questions so far, Riccardo?
So I'm understanding a fair bit of what I saw to begin with. So I recognize the whole proxy injection or proxy extraction model that you were using for I think it was the membership manager was the first example you showed me.
Yep.
So what we've got here, you've got your proxy for an individual component item identified via the interface coming from your IFX that you've created, and then something is presumably wrapping that, or at least there's some sort of injection around that interface coming from SoEx, which is where all the magic comes from. Is that right?
Yep.
Okay, and then that just cascades all the way down to the next level and so forth. Okay, yeah, I'm good so far.
Okay, and we can dive down into those layers in a moment. What we can do though is show that through no changes to code, but just by firing up a different host. So if we take a look at our program host here, there's not a lot on it other than saying that I've got an improc host and that I want to execute some test code down here. If we go and look at stuff and do one per component, you'll see in the membership manager, we say that we want to host by using name pipe, and in the user, we want to host by name pipe. And this references to your example IFX first, and then down here we have here the
So what are we looking at
client.
here exactly? I'm not sure I follow what we're looking at here. So is this
So,
the implementation of the actual service, the
this is
actual
the
membership
host for
manager
the
service?
service. The host for the
The
service.
host for the service. And how are
Yeah.
those two things different precisely?
So the host is the executable that's going to be running it. So in the first instance with the improc here, we're running everything all in a single process. So if we take a look at the dependencies in here, it's probably a good idea. We'll see that in the dependencies we have references to basically everything. We've got the access that we had up there, we had the membership, and we've got a lot of goo to make things work together.
Okay, so it's all in proc. It's all in a single executable. It's all happening in a singular binary.
Yep. And then if we take a look at these ones that are per component, we'll take a dive in here, and you'll see that it only has reference to the interface, not to the service. And here it's the manager one, so it's got the reference to that. And then we'll close that one, take a look in here, and we'll see that it has no references to the manager part because it's just the access service. And then we'll go down to the client.
Okay, so these are separate that's set up to be separate executables,
Yes.
much in the same way it would be if they were separate Docker containers all running independently of each other.
Yes.
Right. Okay.
And then down here for the client to all this, we've got just the manager interface.
Right. Which tells you, so that's telling the client how to talk to the membership manager. Doesn't tell it any more other than this is the contract you've got with this.
This is the contract, and also like what mechanism you're talking to it over. So in this instance, we've got the one that we're calling for the named pipe, which will be up here somewhere. Yeah, we've got a named pipe client and saying that we're adding a client for the membership manager and that we're communicating over the named pipe.
Can you show me that in a bit more detail if you just open that window a bit more so I can see it?
And this one?
Yes, thank you. Okay, so we've got the client build. Okay, so you're creating the client, adding the client for the membership manager using the named piped binding. Okay, so far so good. There's the host builder, creating applications. So you're building a host. Why do you need a host and a client at the same time?
So this is the client for SoEx. This host builder is the built-in .NET application builder. So this will run your application. Yes. So for us to have any dependency injection, this is the host. So the fact that they call that a host is a little overlapping and confusing. But if I give it a different name, then that will confuse people even more.
Okay, so that's just how you run that's just what you need in order to run.
This is just a bog standard Microsoft Extensions hosting host application builder.
Okay, so that's the one that we all know and love. It's separate host from what you call a host. So
yes.
Okay. And then you've got the test client, and
we'll worry about policies and things later. So that then just builds and runs, and then to make sure everything's started up, we do a callback into the test client. So this actually runs as a background service, but it'll run and then everything will shut down. So we'll come up here and change our configuration to run everything per component.
Presumably, since it's using a named pipe, that's a what they might call a well-known name, right? Yeah. So the client and the membership manager service both know what that named pipe is called.
Yes, so the named pipe implementation does it by convention, which we can dig into in a moment.
Convention.
Just naming convention, and some of the other bindings. So I created a Azure Service Bus Topics that uses naming convention as well, and so does the NATS one.
Excellent.
The reason for this named pipe one, which actually on Linux here is not using named pipes, it's using a socket, is because there's no extra anything to configure to do a demo.
It's a nice way to keep them separate.
Yep. So what we want to do in here in the debug, we'll come across to the component one. So we've set a breakpoint here because we're doing 3 different processes. We want to make sure that the service processes have actually started before we continue.
So you're running the client, the membership manager, and the user access at the same time. Okay.
So you can see that in the debug here, I've got this one. This process has started, and so that's the user host. This is the membership host. Again, that has started. And then if we come back to the client, we'll see we've got a breakpoint here while we waited for those to begin. So if we hit continue, that's it started, and then my client has shut down. So we'll come across here and we'll hit on this again to say go, oh, we need to clear that. And you'll see we've got some pretty colors this time. So you'll see that everything is got some different names across the side here. So if we find this one, you'll see that our name behind the scenes for OpenTelemetry is that it's the membership host executable.
Mm-hmm.
And if we come into this one, you'll see that we're on the user host executable.
Excellent. So fault isolation out of the box.
Yes. So that's running through there. And so whether we're in proc or doing it across everything, we can go set a couple of breakpoints in here. So we can set a breakpoint here and a breakpoint here. And then if I'm very careful in what I click, I can probably run up just the per component while I've got these other ones already in the background. And we'll hit go. We'll see we hit a breakpoint. We come through here, we've hit another breakpoint, so we're debugging across processes there. And hit go on this again, and obviously that's generated another set of traces that took a lot longer because we were stopping. Now, if we halt everything here and we switch back to the in-proc host, we'll demonstrate that again. We can hit debug. This time we've only got the in-proc host running, so these are the ones here. You'll see that they've got no debugging information, so let's get rid of those. And then hit continue. We're down into the user access, and then we're finished. So that's quite a lot to jump across. So we see here though, but we're back all the same color, and that we've got longer waiting around in all these traces.
So what I'm seeing at least off the bat is, okay, you've got this nice way of having named pipes by convention. You're wrapping communications with proxies, which are somehow injecting all this additional metadata, trace IDs, timers, all this type of thing. What about things like security? I mean, is that part and parcel of the framework as well, or is this going on unsecured over the named pipes?
So take the security of the binding at the moment. So
okay, so you define that.
Yeah. So if you're using service bus topics, for example, you'd have to provide your key, or if you're running on Windows, you could provide an identity to manage identity. So if you were securing communication over Azure Service Bus, it'd be the same as any other Azure Service Bus security of like who can reach that endpoint. If we're doing named pipes, then it's who can access that machine. So in this case, I've not included any security because I'm just running on a single machine. There's an example where someone in production is using SQS, so they've got to secure it with their AWS credential to be able to transmit to the queue and receive from the queue.
That makes sense. Okay. Can we have a closer look at what values and metrics get injected into these structured logs? That would be great.
Yep. So you might have noticed here that we've got a call chain ID and this hop count. So the hop count here is really more just an example, and you'll see that also I've got it appearing here on the front of the logs already. So I've got my favorite sets of logs there. So
that's how many steps you are away from the initiation of the call.
Yeah. Okay. Obviously, it doesn't account for things happening in parallel. It's just
so if you just think of it as like a distance from when the call started, as opposed to like an order, that's probably better, I guess. Okay.
And so normally I have something more useful in there, such as the authentication context. So what were the credentials someone presented, and then potentially after you've done that, some sort of business-specific user credential that you'd pull back out of your database and want persistent everywhere.
Okay, how does that work?
So here we've got the flow policy. So as the call is incoming, you can say here copy if it already exists, and then if got here the count context already has one, we're doing whatever logic we want to do here. That's going to copy that, so let's undo that. So we're either popping in a new context in here, and then we've also down here, we've got a set if not exists. So up top for the call chain, we start by just copying it if it exists, and then down here on the destination, if there isn't already one, we set a new one, because that's something we always want to have exist.
Okay.
It's also the case here that if you wanted to just blow up if something didn't exist here, because it should already, then that's also an option. So you'd know that some of these contexts are already validated and exist before you even reach your service if you wanted to.
I think I need to reorientate myself here a little bit. Can we just scroll to the top briefly so I can see what we're dealing with here? So, okay, so this is iContext flow policy. Is this a SoEx construct?
Yes.
It is. Okay, and incoming, and you've got outgoing. So is this is an interceptor of some sort?
Yes. Yeah. It's an interceptor.
Right.
We'll get into how it's registered in a moment.
Right. So what do you call a policy then? What is this SoEx definition of a policy?
Well, it's a policy of what you are allowing across that boundary. So anyone could theoretically insert anything into the context of a specific service, but as architects, we want to know what goes across the boundary. So even if someone inserted something at one layer, it's not going to persist is the wrong word, is to propagate. That's the one. It's not going to propagate across the whole system without you purposefully saying this one needs to be carried forward.
I see.
So it's this copy if it exists part. If there's no copy if it exists, it's not going to propagate forwards on the service requests.
Okay, so this policy presumably is what you attach to the proxy or the or the host receiver, and then the incoming or outgoing as is necessary. You have the context, the ambient context from the source and the destination, and you can monkey around with that however you wish.
Yeah, and so then we come down to outgoing, and then this is where the count context goes backwards. So if, for example, I was to do that, and we were to run it again. So we've commented out the outgoing part. So before you saw there was a 1 and a 2.
Yeah. So if I would guess what would to happen here, it was basically the context would just stop dead, right?
Well, it won't have stopped dead. What was that?
Oh, will it be replaced each time then? Is that what
it should be replaced with the 1, but I think because we're in proc, that demo didn't exactly go as planned. Let's just do per component for the fun of it, and we'll run that. We'll make sure it's definitely built everything.
Where are these policies actually added to SoEx, if added is the right word?
So it's within what we call the IFX part, which is what you choose to build on top of SoEx to glue it all together. And so we'll hit here. Let's add a few more calls in here. Always good to actually know what you're demoing. So we'll run this up and hit go. And so we've got 1, 2, 3, 4, and 5. So if we come back to the context flow policy, and we'll comment this out, we'll definitely make sure that we've built, and we run again. And we hit go. You'll see that everything here says 2. Because in the first one, it existed, it came across, it says 2, but we haven't propagated it back uphill. So if we wanted them to all say 1s, we could remove this set if not exists part, in which case I think it'll go to just not existing at all. That's the call chain context, sorry. That's going to be confused. That must exist. So we'll take that off. And so the next part is, so we've got this context being passed around. How does it get into the logs? So in here we've got some scope properties. So this is to do with your logging and tracing scopes. And so this gets executed whenever we make a trace, or whenever you throw an exception and do a log. And so this is how you choose what part of the context appears in your logs. So you can pass more information behind the scenes, but you don't necessarily have to show it in the logs.
So what do you call a scope here then?
So this is relating to the scope as per the tracing scope that Microsoft talks about. So if we come across here and we'll dive into the hosting and the default pipeline, where we're going default pipeline. No, that's not the one we're looking for. Extensions. That's the main extensions. This will be a good proxy side. Our interceptors. I was right the first time. Right. Yeah. So in here we've got our activities for diagnostic sources. And so what we do then is, as we come into here, we will add these scope properties. So we'll begin a scope on the logger and also on the diagnostic context.
Right, okay.
And so what we do is then pass in this scope properties. So if we go to the definition of that, it does a selection of everything that's passed in from that invoked context and converts that dictionary and just passes it across to the Microsoft libraries or whatever libraries are behind the scenes.
So scope property is basically a way of injecting that extra contextual information into the scope of the diagnostics.
Yeah.
That makes sense.
So it goes into both the diagnostics and any error logging and exceptions that get caught. So that's the context policy in action. So if we close all these tabs, we can see how do we insert it. So if we go look at the client one, we actually did that by hand almost. So up here, while we're setting up, we said we want to attach these policies, and so we added iContextFlow policies to the dependency injection. We just made a registration for each policy that we find. So I did a scan using reflection across that, so that we don't have to hard code anything while we're doing these demos.
Okay, so you're adding the policy to the dependency injector container.
Yeah.
How does it know which services to apply it to?
To all services.
Oh, to all of them. Okay.
Yes. So you could choose which services you want to have the policy on if you have something specific. But then, let's see here, this is basically your code consuming SoEx, so you could choose to do anything here to find them. Just by default, I'm doing an example using reflection. And so this is just for on the client side anyway. So this is just the client who like creating that call chain one and passing it along. So if we come into the IFX for the per component, we'll come in here and we will see that we do the same thing. Come down here for the bindings, the clients, and scan for the context policies and add them here. So you'll see that we've done a very similar thing down here and just registered the context flow policy.
So this is the same thing again, but just for a different hosting model?
Yeah.
Okay.
So you could choose to hard code it so you know which specific one you're doing, but for the sake of these demos, so I can add additional ones, and you could choose to put different components and deploy in different ways for different policies.
Right. Are they actually applied in the container or in the dependency injector container, or are they just pulled out later and then applied
they're pulled out later and applied when you're executing. So
right. Okay. So it's just a convenient way of passing them around. Yeah.
So we've got this part here as we come through for the default dispatch. As you've gone across the binding, you end up the dispatcher, but we'll cover the direction of all that later. We've call flow incoming, so we have the caller context and we have the context for the operation, and then we flow the context back to the caller here. So
Flow the context back to the caller.
Down here.
Okay, right. So that's on the return journey, effectively.
Yeah, that's on the return journey. So there is an explicit line where that happens within the SoEx framework, but in terms of whatever you're building on top, that's just happening automatically for you.
Mm-hmm.
So that's the context flow. In terms of the IFX, so if we take a look at the proxy, so we spoke about the proxy earlier. All we've got here in your example IFX is that you're referencing your IFX, so you can control whatever versions. You can put any extra checks on here that you want to do before allowing someone to get a proxy that reaches a service, but then it down here calls through to the SoEx implementation. So very, very lightweight.
Mm-hmm. So if I wanted to add something to the context,
Mm-hmm.
how would I do that from, say, the client? If I'm writing the client or I'm running the client and I want to add a piece of information which I know is going to get propagated, how would I do that?
Okay, so normally we'll be adding it on the service side rather than explicitly in the client. It is possible for the client to add something, but usually we're not fully trusting the client. And so here within the IFX of the service, given a helper in the templates for context of T, which is whatever your context class is, and with a property to be able to get the specific thing resolved from the ambient context, and the ability to also set the context. And so we're doing a set if not exists in here. So if someone was to try and set it directly outside of a policy, in terms of the IFX we've set up, we're not going to overwrite something that already exists. But if you wanted to change that in terms of how your systems interact, you can actually change that here, because this part isn't part of SoEx, it's just part of the template for consuming
Mm-hmm.
it.
Okay, so if I wanted to add some information to the context to be propagated, can you show me how I might do that?
Yep. So this is the definition of the co-chain context. So it's literally just the struct. Can be a class, but this one does here. And then we've got like our count context here. And so we see that we've set it up so that you can get just a new one, or you can pass in itself because you want to do something with the context that refers to how it's chaining on down its path. And so we could create a new one here. So we can add a new American destruct. And what would you like to call it?
Oh, Blair's context. There you go. Does it have to be a struct?
No, it can be a class.
Okay.
And do you want me to make it a class here?
Yeah, why not? Let's mix it up a bit.
And what would we like to do with it?
I just want to pass a GUID, something. Let's keep it simple.
Okay. And do you want to call it just ID?
Yeah. Just keep it simple for now.
And do you want, in this case, just to be able to set it this time explicitly rather than the magic?
Yeah, I'd like to be able to set it and then to... Actually, you know what? Just to make it easier, let's make it a string. So let's just make it a string ID, and that way we'll know that we're definitely setting it. So
okay. So we've got a string ID here. We'll go down to the policy. And what we can do, say here, is... And in this case, we don't want to automatically set it, but we just want to copy it if it exists. So what we'll do is here, and then we'll Riccardo's context. And what have I not done? Must be non-nullable value type.
Oh, that's is that the
Yeah.
ID?
So no, it's be this part here. What have I done? It says it's never instantiated. Is it because... Right, I'm just going to make it a...
Oh, is that why it's got to be a struct?
No, it works anyway. I'm going to make it a struct for the sake of this demo, but they were originally classes, then someone asked me to make them that. Let's make it init. So, because we've done that, because we don't... we don't want anyone changing them after they're set anyway.
Yeah.
The original ones were classes, but we'll stick with the struct. And so
Okay.
if we go and we'll leave ourselves as the improc one for the sake of handling that, and then if we come into the context, what we can do is we can copy this, and this is just a helper method to whatever the current context happens to be. And so we'll come into our host and to here. And so, so after we've opened our request scope, so if you're using something like ASP.NET Core inside of a controller, our request scope already exists, but because we're in a console application, we have to explicitly say that. Import types, and we will context. This, and in this case, though, we don't actually want to get it. We want to set or replace, and we've got a new part of context, and ID equal to hello SoEx, just to be traditional.
Sounds good.
Right, and then what we need to do though is we need to find out if that ends up somewhere. So if we hop all the way down the end, and we'll go into access.
Just a quick question: the container that you mentioned there, is that the container that you mentioned previously? Is that a special container, or is it just a reference to the dependency injection container?
This is the reference to the dependency injection container.
Okay, right.
So we will wrap that in a undo. We'll wrap that in that and hit dot. And then we need to follow up and import missing references. And is it pulled the wrong reference or is it the right reference context? Not valid at this point. What have we done wrong? There we go. And it's not happy with this one because, right, not sure what's going there. But anyway,
is it the namespace or something? Or?
Yeah, it's been a while since I did the demo of all the parts. I think there's just a slight conflict between the changing things. I think it's because the version that I'm using, I upgraded SoEx itself, but I think this is running off one library version before.
Okay.
So we'll hit that, and so obviously there's nothing being passed here in terms of data contracts or anything. There's absolutely nothing there. We'll hit debug. And here we go. We've got your context, and it says hello SoEx in it.
Fantastic. So I can pull the context out whenever I want.
Yeah.
So what is that? How is the context actually made? What's it built on top of, under the hood?
Okay, so the context is made up on two components. It is a scoped, a per request scoped interface pulled out of AutoFac. And it is also that policy part that we looked at earlier to be able to copy in both directions. So if we come into abstractions, is it up here? No, we don't need to worry about that. And we'll come up to here we've got the folder. Yes, we do have an abstractions part. So we've got the context itself. So ambient context, we've got set if not exists, gets, check if something contains, and set or replace. And so it can take anything that is not null. And then we have some extensions for the copy if it exists extension. And so that's what you reference. And then when we're running, we have an implementation of an ambient context that basically just stores it all for you in a dictionary.
And the dictionary is where is that kept?
So that is handled. The lifetime of that is handled by AutoFac as the dependency injection container.
Okay.
And
Nice.
so if we go back to the default dispatcher, this is the part that makes the magic happen, is that we resolve it from the request lifetime. And I suppose the other part to look at to do that is when we register it in the host extensions, when we register the ambient context, we register as instance per lifetime scope. So this instance per lifetime scope is a specific, I don't know why we jumped there. Let's go find it again. Instance per lifetime scope is a specific terminology as part of AutoFac. So I think within other dependency injectors, this specific lifetime doesn't necessarily exist. Which means regardless of whatever else happens, once we go through one of these steps of creating a new lifetime, it will persist within that lifetime. So even if you request it within a few different dependencies, as long as it's within the same lifetime, you'll get the same one.
Right. So you need to understand AutoFac to
Yeah.
basically understand the underlying
And so you'll see here, we
machinations.
begin a new lifetime scope. So as part of the dispatch of each service, we begin a new lifetime scope. And we have the ambient context here that we're resolving for the operation. And we already have the caller ambient context. So you'll see up here that we deserialize the caller ambient context from the request. So it's passed along as information as part of the request. So if we are passing this through something that's not in process, like the named pipe or over a service bus, it gets serialized, it gets attached to the message body, it comes through, we extract these parts as our own headers out the message body. And so we have whatever the caller ambient context was, we scope it within the lifetime. And so then once we've done that, we ask for one, and so we've got it. We then do whatever operation. The operation can do whatever it wants to do on the server side with modifying the context, and then we flow it back to the caller using the policy. So if there is something that you set that you are allowed to set and can be passed back up the way, it will. If you've set something that's not allowed to flow back upstream with the request, then it'll be completely ignored.
Okay. Fantastic. All right. So I guess there's a hard dependency on AutoFac then if you wish to use this. Is that right?
Yes, there's a hard dependency on Artifact. A lot of
Okay.
other things you can swap out, like you can swap out the logger, you can swap out what your tracing provider is, but it does have a hard dependency on Artifact.
Okay. I can think. I guess there's worse things that there could be a hard dependency on than
Yeah,
than
I think
AutoFac,
it's
which
like
is a
it's almost the only one I think. There's potentially another, but I think it's the only one I can think of. So something else we can take a look at as well, though, because it will get us looking at the topologies as well, is for testing. So if you want to unit test, we can come down here, and we've got test runner. So let's move this down so we can actually see what's in front of us. So if we want to test with real implementations, you can tell the test harness that you have some policies. So there's where before we were scanning them at runtime for the runtime, as part of your test, you can say which policies are involved in the test, and then we can manually build the topology. So this topology here actually exists in what we were running earlier, but with the library SoEx method conventions, that gives you the default for how to build these topologies using terminology like managers, engines, and accesses. But you can actually host anything in here, so any class and any interface. And so we have a top level part here called the topology, which we define as a system. And so the system has subsystems, and it also
So
has.
sorry, what are we looking at here? Is this part of the testing suite, or is this a separate part of SoEx?
So the topology part is inherent to hosting anything in SoEx, whether it's the inproc or the components that we've just had a look at,
Okay.
or as part of a test.
But we didn't see this before, so was this living somewhere behind the scenes?
That's what I'm saying, is built by the conventions. So if we
Oh,
take a look in the IFX into conventions here, we have a topology builder. and then this builds up on top of some conventions here that say like add manager,
I see.
add an improc endpoint on it, and things like that. So normally this is hidden away, but it does exist.
So what does that do? What does the topology actually do?
So it's how you define what your entry point is for a system. So at the top level you have a system. So a system is built up of subsystems.
Mm-hmm.
And then so each subsystem has an entry point, and so that would be our membership manager. And you can express which endpoints you have. So in our case, we only have one contract, so we only have one endpoint. So you could have either multiple contracts with similar bindings, or you could express that contract over multiple bindings. So you could put it out over both SQS and Azure Service Bus if you wanted to have some sort of multi-cloud failover or something.
Why is this necessary exactly?
Because you have to express what your contract is, what your binding is, and what you want to host it.
Well, let me ask a clearer question. Why is the topology necessary? What difference does it make? If we didn't have the topology, what difference would it make?
So without the topology, in the first alpha that I made, it didn't have a topology. It just hosted everything all in one massive dependency injection namespace.
Mm-hmm.
But you then lack isolation between certain things that you might want to separate. So if you were to host all in proc, you have less, without the topology setup, you have less separation than you do when you're per component.
Separation?
Yes, so if you were to register some sort of underlying dependency to do with a database or something, you'd have to resort to keyed dependencies or similar to be able to disambiguate between which dependency is loaded into which access.
Right, okay.
Whereas with if you did that in proc, you'd have to do that. If you then deployed per component, they would naturally be separate because they were independent. So here, this allows us some isolation. So within each host, you define what the implementation is, the endpoints, the proxies. You can also define, is it going to autocomplete for me? A service collection that exists per host. And so this service collection is scoped to just that service. And so nothing bleeds over between the manager and the access or between different accesses. And so we'll come back. So each host can only have a single implementation. It can literally only have one implementation. It can have as many endpoints as you want. And then within that, for that host, we explicitly define which proxies it has for it to communicate over. So in this case, we've created a proxy for the iUser access, and we've told it that it belongs to the subsystem membership. So you can see why we made some convention helpers for this earlier. And so within this subsystem, we then list the components that exist. And in this case, we just have the one component. It has no proxies because it's not going to speak to anything else. It's at the bottom of the tree of calls. And so it has a binding for the manager to call.
I mean, you could stitch this together by hand on a per component basis, couldn't you? You could say explicitly, I want the membership manager to talk to the user access and nothing else.
Mm-hmm.
This is just laying it out explicitly.
Yeah, very explicitly. So
yeah.
This allows you to very explicitly create subsystems. So one of the ways that it's discussed that you can deploy something using a method system is that each manager should have its own instances of the engines and the accesses. And so by implementing it this way...
In proc, you mean?
Yeah, in proc or even in deployment. If you're deploying extra Docker containers or something to host it by some sort of convention, otherwise you'd want to isolate them so that the ones that a specific manager uses, even if another manager uses the same one, you'll be hitting different instances so that as you do rollouts and things, you don't take out the other one by mistake. Just to do with versioning and dependencies. Okay. So this allows you that separation.
So when would one use the topology explicitly like this, as opposed to having it rolled up in the background?
So right now for the test, you're forced into it because I haven't made a convention for the test yet.
Hmm.
Um, but an example that could exist, because you can name the subsystem, here is you can actually model more complex deployments. So we're thinking here where we only have like one membership manager and there's no interactions between anything else. We could think about a fully distributed system and still host it in proc for testing, whereby maybe we have a membership manager in my house and a membership manager in your house, and they communicate the changes over some sort of feed manager to interact between each other. And so we could
Hmm.
actually um, define with the implementation that we have two membership managers and two feed managers, but we'd give them a different name in terms of the subsystem. And then the proxies here within each manager is only to its own component within itself. It can't, any improc bit here can't reach to another subsystem. It's blocked, and it won't find it. But then you can explicitly define a client that at the top level here that the managers have. So the managers, if you were using like the feed managers, could explicitly know about the events from the feed manager to communicate between each other. And so you can put the same components in, but with different isolation to model like different actors in a deployment.
Okay. I'm just struggling to understand why that would be necessary. What's it preventing you from doing? I guess is the best
Right, so
question.
the first thing that it prevents you from doing here is if you were defining in your architecture that you've got a membership manager and an analytics manager, and that the user access is only allowable to be accessed by the membership manager, not the analytics. At runtime, that can also be enforced by the fact that they're not listed as a component and it doesn't have a proxy to it. So in a lot of existing systems, you can cross-call between your services that are hosted in whatever fabric you're using. You can cross-call between them, and there's nothing to stop that. If someone accidentally just copied something into a service implementation, but once you're hitting deployment here with the topology, when you deploy it, if it's not in the topology, it's not going to have a proxy for it, and then it will explode when you try to resolve the
I
proxy.
see.
Oh, I know that
So
binding. I don't have a proxy for that. It doesn't exist.
I see. So it's a level of architectural enforcement, is
Yeah.
basically what you're saying here. Okay. I mean, theoretically, people could change this code as well, right? But presumably, this is for instances maybe when you might have, say, dynamically loaded libraries or something where
Yeah.
you don't necessarily know what the implementation is going to be, but you want to make sure some things are only allowed to talk to other things.
Yeah. I mean, the
I
case
get
is
you.
yes, someone could come in here and add it explicitly in, but you probably looking at the topology is a little bit closer when you're doing your code review than what someone's
Yeah.
doing in a specific implementation. So if someone starts
Yeah.
doing something that's not in the architecture, it literally can't call it at runtime without you
Yeah.
having
If
a
you're
big change.
if you're going in editing this, you kind of already know what you're doing, and so you're doing it deliberately at that point, as
Yeah.
opposed to doing it accidentally. Yeah,
Yeah.
I get you.
And so this also, then, as I showed with the service collection, allows isolated service collections between the services, which gives you the same isolation in proc as you do per component. Something that we didn't demonstrate earlier, but we do have a
When
bit
you
in
say
that index.
isolation, when you say isolation, you're talking about the ability to communicate between them. You're not talking about encryption or anything like that. It's just basically drawing up a barrier
Yeah, just
to.
a barrier
Okay.
in memory that says I'm asking for something, but it goes, I don't have it. It doesn't exist.
Yeah. Okay. Where is
Um,
this enforced? The topology itself. Where is that part enforced?
this is enforced by your dependency resolution. So all your dependencies and your services and your binding and everything are registered in nested containers within Autofac. So that's another part, is that you can register child. Basically, it's a root within Autofac, and then every time you make a request scope, it makes a child one, so it takes everything from above, and then you register whatever is specific within that one. And so each actual service implementation and hosting of a specific one inherits what we have of the framework, to say that we have the ambient context and such. They're all registered at the start. but then each host then only actually gets what was explicitly defined for it. If you go and register something for a different service, it doesn't know about it. It can't know about it. And once it goes into its resolution, it's not there. Something we didn't go into, we've gone into improc and per component, where everything is its own process. There's also one called subsystem, so where each manager would get its own process, but whatever's hosted with the manager will be hosted in proc within the manager. And so the topology gets more, it's sort of more relevant to the in proc and the subsystem ones than it is to the component one. But it's defined the same regardless of where you are. So we have to define these topologies in order to run a test. And so if we're here, we come down, we set up a service runner, and we call whatever operation it is we wanted to call. So we need to go back and set a couple of breakpoints again. We should probably close that off so we don't hit it too many times. I'll go up here.
The test harness you created, I'm guessing there's something special being leveraged in AutoFac that makes it a test harness?
It basically is just a mini version of
A host.
Of the main hosting, actually. It's surprisingly similar. It's just a cut down version of what happens in the inproc process.
Right.
So where you would explicitly be saying which bindings and things you want to use. The inproc one, the testing one here, basically will always be using inproc rather than whatever other binding you have. So if we hit here and hit debug, we will shortly see that we come through our test and we hit our breakpoint, and then we don't hit our other breakpoint. Did I not set it? User access, I think it did. It says it succeeded. Oh, did it run all of them? Let's try again. So we're at our membership manager. We hit continue. Have I used the wrong one? It says it's real ones. We've got one here with a mocked access. So we'll take a look at this one as well. And then we will hit this one and see if this one does something a bit different. So this one hits our membership manager and then ends. Okay, so this is not a good example in Rider. Rider's letting me down.
Okay.
I was using Visual Studio Code for these before, but then Visual Studio Code has a bug in it that breaks name resolution within the project file. So so I had to give that up because I found a registered bug. So it's like, okay, I can't fight that if someone else has actually acknowledged it's a problem. So who knows? So that seems to be consistently not demoing nicely.
So just to clarify for my own understanding here, when you talk about in proc, I just really want to understand how this all sort of fits together. So, you and I, we both worked with WCF in the past, where we had, quote unquote, in proc services and so forth. But that was separate. That was a host which would spin up separate WCF processes in the same service or in the same executable.
Yeah.
So there was a very high degree of process isolation there. That's not quite what is that the same thing going on here, or is it simpler than that?
No, there's simpler than that. So if you're doing everything literally in one process, it's one process. How it's actually implemented is that we'll end up with two application hosts in terms of that application host we talked about with the .NET one. So let's go find the single host up here. And
but they're still running in the same application.
Yeah. So we'll come. Okay. So we've done this in the IFX. So we'll come down here, and so we'll have the service host builder, and we'll have a client host builder. And then so we register this as separately. So I returned back the two service host builders, and so the reason for that is to make sure that everything is registered and has a full lifetime and is isolated in terms of the host. It makes it um, more like when you've got separate processes, but everything to do with what you're hosting in terms of the components are all in this service host one, and this client one is here so that you can actually communicate with that. Because if you're trying to register the client within this, then timings of starting things would be a bit confusing.
Yeah,
But
for sure.
you don't need to necessarily have one here called client. So this one could be your ASP.NET Core host that you normally have. So that would already exist, and you just add this service host builder one in addition. And then you would register your things in here with the client topology. So the client topology would just be your list of proxies that you want, and wouldn't need to know anything else other than like what the binding and the contract is. But
That makes
otherwise,
sense.
absolutely everything is in here. And if you're doing improc, it doesn't go, literally doesn't go out of the process at all. So the binding itself, this is going to get a bit technical. We come into the transports and into the improc, and we have something here for all the improc listeners. So we actually hold a dictionary of all the improc listeners, which have addresses that involve the subsystem name and the contract. So if we come into the channel, we would see that we are actually putting in an address for the improc one as well anyway. The reason for this is I actually did it purely based just on the contract, but then when I spoke about those more involved examples of hosting the same thing more than once, and that was something came from someone who wanted to use it for that purpose. It's like, right, okay, I need to isolate this more, and my contract was literally being an address. I just wasn't treating it as an address. And so it has here a list of like what the addresses are, which then you can resolve the specific improc endpoint, and then once you've resolved the endpoint, you will speak to the underlying artifact container while you're doing dispatch.
Right.
That's a lot of information. I don't know if that makes sense.
No. It's all good. It's all good.
So it literally is doing in proc. It's literally doing everything in memory in a single process. Like it does, nothing goes outside of the process in terms of the SoEx in proc.
So in order to have true, um, in order to have true process isolation, that's when you require. That's when you have to spin up separate instances, separate hosts, separate binaries,
Yep.
and have them essentially sitting alongside each other, which you can still communicate over well, whatever channel you want, really, whether it's named pipes or otherwise.
Yep.
But that would be what we would have equivalently called like a separate WCF service, but all running individually, because we don't have a modern day equivalent of WCF to actually manage all that for us.
Yeah. So if
Okay.
you're running actual separate processes, that would be what we were demonstrating earlier as per component.
Right, that makes sense. Okay, so you've gone quite granular with the configurability here, binding channel, endpoints, transports, and all sorts.
Well, so the inproc binding here for itself gives you specific information about like what your contract is, which the subsystem is, and what the transport is. The transport down here actually just gives you the types for which channel and host channel, which is the endpoint. So you just specify that there. So that makes it easy for us to pull the binding and the transport, and then just do everything by normal type resolution. So adding a new one is relatively simple, as we can come in here, and for the event transport, we will see that we've got a service bus topic event channel and event endpoint. And if we just come up to, where's just the normal one? I don't do normal request response in that one, so that one only has the event.
Because that's a one-way call,
Yeah,
isn't it?
that's a one-way one. So we've got the name pipe transport, so that would have the name pipe channel and name pipe endpoint, and then also have event transport here. So name pipe event channel and that, and then we'll see a repeat of that pattern here with NATs, where we have an event transport, which has an event channel, an event endpoint. You could call these anything you want, but naming convention makes it easier. An example of an extra request response only one is the Azure Relay. So this is an Azure Relay example. So you can do request response between two endpoints that have completely closed out firewalls and don't listen to anything. So you can just use the service calls up to Azure using the HTTP relay, and then your client goes to Azure with the HTTP relay, and then the client has no idea at all about where anything is hosted. It's also technically possible to mix and match these. So I did an example where everything was in proc apart from an engine, and the engine reached out over the relay. So if you want to deploy something where you deploy most of your product out to the client, but you've got some sort of secret part that you don't want them to be able to decompile, just for that part, even if it's in the middle of your system, you can use the bindings to make it hostable anywhere.
For sure. Okay. So interesting. Okay. So I think I'm getting my head around this. I'd like to learn more about the logging and the telemetry and all that. If now's an appropriate time,
Yeah.
unless you wanted to cover something else first.
No. So in terms of logging, telemetry, and some of that other stuff, that probably means we should discuss interceptors a little bit as well.
Sure. Yeah. Absolutely. I'd love to.
And so when we're registering things, let's see what we've got. So we'll look at diagnostics first. In here, I've just got diagnostic client and host and their names.
Okay.
Then,
so some conventions for activity sources.
Yep. And then we'll come into the hosting, and we have, where's the default pipeline? We'll have a default pipeline. And so as part of your topology, you can specify, and you can a default topology across everything in the topology, and also on a pair binding basis, you can also override this. And so within here, you can override your dispatcher, you can override your message serializer, and you can also override any interceptors. So you can.
So can you just explain again what the dispatcher actually does? Is that just the thing that stitches the messages together?
So the dispatcher is the bit that actually calls your code, the service code in the end, the bit that actually news up the class and invokes the operation.
Right, so does that sit on the server side?
Yeah, that sits on the endpoint side, on the host side.
Okay, so it's receiving it and then dispatching it to the actual code that you've written. Okay, that makes sense.
And so these service interceptors, I haven't implemented interception on the client side, so your default pipeline is included the client as well because of the message serializers, but it will totally ignore what's here. So an example of an interceptor is this error interceptor here. And so we'll come in here, it's just a Castle Dynamic Proxy I interceptor, and you can do whatever you want in here. And so all we've got here is that it says log error and logs the message. And so you can put as many of those in as you like, and that'll happen after all the dispatching that we've done. And these get registered again in the hosting at the beginning, so you don't actually see them in the SoEx framework after it's been registered. So in terms of what happens in here, so I think what would probably make more sense before we speak about the dispatcher and how that gets invoked is if we go find one of the transports, and I'll take a look at, say, the named pipe transport and the endpoint here. So you'll see that we choose to listen to something, and then we've got our callback that happens. So we get our bytes, and then we call to dispatch, and it's in here that we go get the endpoint pipeline, where we then get a reference to our service pipeline, which if I go declaration of, I want to go to implementation.
So pipeline is pipeline. There's nothing to do with named pipes, is it?
No. This is just generic.
Right.
Everything comes into this. So
what's it a pipeline of? Is it a pipeline of
what happens with the call?
dispatching?
Yeah. So we've got a client pipeline and we've got an endpoint pipeline, and so
okay. So it's like layers of an onion.
Yeah.
like they used to have. Yeah, okay.
Yeah, so I probably should have actually started the client pipeline, but we're here now. So this is where we resolve the dispatcher, we resolve the message serializer, we go find our lifetime scope and get the host for whatever you got. We create the lifetime scope, we resolve the dispatcher, we resolve the serializer, and we then call dispatch on the dispatcher.
Okay, so you receive the message, you deserialize it into an invocation request, and then the dispatcher dispatches it to the pipeline. Is that right?
So the pipeline calls the dispatcher.
Okay, right.
So the pipeline goes and resolves everything that you need for doing everything, and then we'll come into here, and this is where you come down, we do all the things we spoke about earlier, we resolve the type, we find the method, and then this is where this is the line that actually invokes your call.
Yeah, this looks familiar. Okay. Right.
And then it'll do everything again in the reverse order. So if we'll come back out, that so here you've had your invocation request is this is part of SoEx, and so it would have deserialized your request. It sends the request deserialized into dispatcher, which does all the things of like how to invoke it, and then once you got it back, it will reserialize your response using whatever you defined in your default pipeline, and then return that to the user. So if we go find...
so this is on the way in to the
Yep.
service, is it?
Yes. So
What happens on the way out?
Well, that wraps the channel on the endpoint side. So that wraps the endpoint on the host side. So that will have done everything. So if we go look at this here, so this is where you'll see that it deserializes before and serializes after, and then it just returns the response.
Oh, I see. So the line where it says dispatch, that's where the actual call to the code is happening, and then the response comes back, and that's what your code is actually returned back.
And this service pipeline is what that named pipe endpoint called. And so that's where we can do everything specific to your communication over whatever transport is isolated in the endpoint. It then calls the service pipeline, which is a bit that you won't substitute the service pipeline because it knows what step everything has to happen in. But within the service pipeline, that's where your pipeline configuration that we showed earlier goes into, which means that in there you can then change the serialization. You can change which dispatcher actually gets invoked. I haven't done an example of where you would replace the whole dispatcher, but I have done an example where you might decorate the dispatcher. So in here we've got it resolves the dispatcher, and so it calls the dispatch. And so in here, if we go to implementation, you'll see that I've got two of them. We've got the default one, which I've just shown in here, which is where we showed this is where you actually invoke your actual code. And for development purposes, I have got, we'll have to go back again a step.
So you're using method invocation here. Why do you need a dispatcher to do that separately? Why can't you just invoke the method directly from there?
That's for all your extra pieces. So this service pipeline happened after. The first thing that was created was the dispatcher.
Okay, so even though it's being used there, it's actually existed since the beginning.
Yeah, since the beginning. This service pipeline happened after as a way for you to, one, be able to override the dispatcher, and two, be able to change your message serializer. So you could use different serialization on different bindings.
I think I need to see some examples of when and why you would do that to understand why that's important.
So in terms of the dispatcher, if we go here, we could do a decorated dispatcher. So rather than doing an entirely different one, you could, as part of dispatching, if you wanted to do something extra, you can do that before and after. Does that make sense? I know this one's very empty, but you could choose to do something here. So rather than re-implementing the dispatcher from scratch, I don't imagine anyone would want to do that. But if you wanted to do something before or after, you can do whatever you want in here. This just gives you just an extra interception point.
Right. So which happens first then? So the interceptors you created there were built using async interceptor from Castle Proxy, I think. Is that right?
Yeah. So those happen after dispatch, but before invocation of your code.
They happen after dispatch, but before invocation.
Yeah.
Okay.
So you'll be coming in here. I do all the things with the context and everything up to here, set the logging scopes and everything, and then when we hit resolve here to get the method and the host, when we hit resolve here, this is where those interceptors from that Castle Dynamic Proxy were registered with your original class as the implementation type into Autofac. So when Autofac returns this concrete example, it has already put the interceptors around it.
Okay. And can you just show me the pipeline again so I can see how the dispatcher fits into that? I'm just trying to sort of get my head around that.
Getting back here. Navigation here is not as helpful. So this is the service pipeline. So this is just to choose with if you want to override anything to do with the dispatcher and if you wanted to use customized serialization.
Right. What's the difference between an endpoint pipeline, a channel pipeline, and how many other pipelines are there?
Too many.
However many there are. Default pipeline. What's the difference? Why do we need different ones? I mean, what are they doing that's different?
Okay. So the default pipeline is your configuration of like what happens within the default that happens within that service one. So we're looking at the pipeline of what happens during your service invocation, and so it's are you going to do anything with modifying dispatch, and are you going to do anything with modifying the serialization? And this is also when you register is like are any interceptors being registered on your service side? Yep.
So why would we need anything other than that potentially, or some sort of re-implementation of it?
Well, this is the point where the service pipeline is the point of implementation for how you actually make these change.
Okay, so you've created a channel pipeline, which is a bit different.
So the channel pipeline is just the proxy side, the client side. So this service one that we're talking about only happens on the endpoint. So let me just close these down. And so on the channel side of it is where we get the serializer type, we serialize the message, and we call the channel. So we invoke on the channel, and then we get a response, and we deserialize it and we return it to the caller.
I see. So this is client side.
Yeah.
This is the client side equivalent of what we were just looking at.
Yeah.
Okay.
And so there's less to override here. And so if we go look at the implementation of a channel.
Okay, I get it now. So channel is client side, endpoint is service side.
Yeah.
Right. Okay.
Which is a little different to WCF where it said channel for everything. Everything had a different
I think
channel.
That's why I was getting a bit confused, because channel was kind of a ubiquitous term there. Okay. So
if we take a look at the relay, for example, and we look at the channel of the relay, this is the invoke result that we just saw. So across here we see channel invoke results. If we're using the relay, it goes and gets us a token to speak to it, and replaces stuff to hit the HTTPS endpoint, and then we literally make an HTTP message, send it over HTTP, get it back. If we wanted to look at, for example, named pipe channel, it's very similar. We've got invoke result, we get the client stream for the name pipe, we connect to it, we get stream bytes, we write bytes, we read back the response bytes, and then we return it to the caller.
Right. I think now that I know that channel is client side and endpoint is service side, it makes it a lot easier to understand. Okay,
I meant to do that at the start as here's the things that are different to WCF, but got carried away.
Sorry. That is as much as my fault for asking too many questions. So binding and transport, are they used on both ends, or are they client and server side specific as well?
So that is just used on both ends. So when you specify the binding, you specify all information, and not everything contained within that is used everywhere, but it's basically just definition of types.
Right. Okay. What's in the server folder? I just saw that at the top.
Oh, the name type one. That's some code I've borrowed MIT license from Microsoft to handle the name pipe stuff.
Oh, so that's an implementation specific aspect of name pipes.
Yeah.
I get you. Okay.
So as I said, like with everything else, that's something that you, like with NATS, would run the NATS server. With service bus, we either connect to the real service bus or the emulator. Whereas for named pipes, we actually had to handle on the Linux side, we have to handle the sockets and connecting to it and things.
Do you need to run it in a special way in order to make that work, or does SoEx handle that for you?
SoEx just handles it. I
That's
basically
nice.
only use the named pipe one for development and examples and demos and things. I would rely on something else for production if you're not on Windows.
Really? Oh, if you're not on Windows.
Yeah.
Okay, yeah.
And
That
if
makes
you are
sense.
on Windows, I still need to do an update to compile the Windows specific parts because I don't actually publish to NuGet the OS specific packages yet. I'm just doing the one, so coincidentally the socket one still works on Windows. But if anyone wants to use it in production, then I need to do that deployment. But
I mean,
thankfully,
named pipes in WCF were really powerful because it meant that you could have very fast communications in the same, across services, but in the same, effectively in the same binary.
yeah. But, my deployments personally have all been on Linux so far, so I don't have a need to do that
Yeah.
Windows
Well, I was
code.
going to say you don't. I was going to say, as we said before, you don't have that same level of isolation, and so named pipes, it's almost redundant there, isn't it? It's almost unnecessary, apart from the examples you stated.
Mhm.
So,
It's super useful if you wanted to run stuff in literal separate processes. Then named pipes on Windows is the easiest way to connect them, so it
that's
still
true.
has value.
Yeah, that's true.
But
Yeah,
if you're
that's
doing
true. That's true.
if you're doing entirely in proc, then they're not necessary like they used to be with the WCF way of doing it. Um, but if you wanted to do things per subsystem or per component to do process isolation, then named pipes would be a good option.
I guess that'd be nice if you had the old-fashioned Windows services installed on your machine, running side by side. That would be good. Yeah.
Mhm. And for example, I've not created an MSMQ binding in here, but for our events, combining named pipe and MSMQ on Windows would be a good combination of transports. But while I have a Windows machine that I do some development on for some clients and things, in terms of all my deployments of stuff built with SoEx, that's all on Linux at the moment.
Okay. So where do we go from here? What's the next thing to look at?
So we were talking about how different things get done in terms of logging and stuff. So in terms of logging, we've got that error interceptor.
Yeah. So you said that in order to look at interception and logging and telemetry, we'd have to go through dispatchers and interceptors and all sorts. So
So we've got the default error interceptor. We've discussed how the error interceptor ends up getting set up, and so we just capture the exception and log error. And so in here, it's the iLogger from
okay. So we're back to dependency
logging.
injection.
So for example, when I do an implementation on top of this, I will register into the DI to use Serilog. But this SoEx says nothing about which actual logger. So in your IFX, so like I had the IFX out, in your IFX, you need to register a logger specifically into the DI, otherwise you'll have no logging. The templates include Serilog as a default. And so that'll happen there for the logging. In terms of the dispatcher, you see that in terms of tracing, we start the activity here. And then if there's any exception, we will set status as error, and then that returns it. So you've got that in terms of the logging and the tracing actually happening. And so in terms of how long the timers and everything is all pulled from this start activity one. So all the timing is built in with the usual stuff. And then in terms of actually getting that somewhere, that would be in here in your IFX and observability. We've got some observability extensions where you just say, configure telemetry and configure logging. So if you wanted to change to use something else to instead of open telemetry, or if you wanted to change what your endpoint is in here. So I've just used Seek as my endpoint for telemetry, which I'm also using as my endpoint for logging. If you want to override any of this, this is where you would change it in one place. And if you changed it in this IFX observability, then you've automatically changed it across improc per component across every kind of hosting you've got in here. You don't have to do it this way, but the template structured this way to make it very easy for you to change.
Yeah, So, I mean, we're talking about essentially auxiliary services that or components that run alongside the standard things, the plumbing, effectively.
Yep.
Um, what about configuration? I mean, if you wanted to, so say I've got an isolated binary for a membership manager, and it needs to talk to a user access, which is on a web service somewhere.
Mhm.
How do I configure it to tell it what the endpoint is?
So that will be where you define the topology, where you register things. So for example, if we take inproc in here, we have the host in here, and it does its stuff for building the clients and adding the clients. Was that the scanning I did in here? Let's have a quick look. Yes, we did the scan up here. Here we go. Yes, we did all our scanning here. Yeah, it's this topology builder build here. So by default, we're in here and we're just registering everything. And so that topology builder is over, if we come in here and look at the method conventions and into the system builder. This is where there's a lot. We've got our entry point, and we'll automatically start adding endpoints and rebuilding the host with whatever the implementation proxies and service collections, and then we'll add an inproc endpoint and build stuff up here. And so you can add, specifically call to add a proxy, and you can specify by passing in the client here, and the client will contain a binding, and your binding will contain this specific address if you're doing it by hand.
And how would you do it by hand?
So let's tell you what, let's look at the examples up here. And if we come into the host and we'll pull single and run. Here's an example of doing it by hand. And so, like for example, here I've got the relay binding. So I've said the Bravo binding here. I've defined it just as a static up here at the top because I use it in two places. And so for the Bravo event, I've added the proxy here onto the alpha subsystem and said that it's the event binding and belongs here. And then further down, when we find the Bravo subsystem, I add an endpoint this time instead of a client and pass it in the Bravo binding along with the event binding.
So for the Bravo subsystem, you have the end. Okay, but these are all still in proc, though, aren't they?
Yes. So I did put this in proc, but you'd do the same thing if you're doing it in a separate process.
Oh, you would. Okay.
You just wouldn't have all the other steps.
What if I wanted to do like a RESTful endpoint and I had to sort of name it, like literally give it a URL to say, right, here's a RESTful endpoint which is using gRPC or something like that?
Mm-hmm. Well, then you'd have to pass in a configuration. I'm not going to open this configuration because it contains my actual credential. I'm not going to put that on YouTube.
That's fine. Okay, so that goes into the configuration object that you've put there.
Yep, and that configuration object is related to the binding, not to anything else. And so you could write your own binding that takes whatever form of configuration you want.
Yeah, that makes sense. Okay. Out of interest, do you have a gRPC transport and I forget exactly what you called it, binding and endpoint and all that sort of stuff?
No, I've not done an explicit gRPC one because I've not needed to. In the alpha version, alpha 1 version rather than alpha 2 version, I did set up hosting on top of Dapper, and Dapper uses gRPC. So if you went back into the commit history, you'll be able to see an example of it built against the old way of building. But now that I've separated transports out and made isolation bigger, I actually need to copy it across at some point.
But you could do it.
But you could do it. It actually, the implementation would actually be simpler in the Alpha 2 than it was in the old version. But all the code that you need to use basically already exists there. But we'd basically do wrapping would serialize in whatever we've got and then pass it over just a gRPC that just wraps our message rather than having to make the whole thing understand gRPC. is the easiest way to integrate it so that you don't have to do any extra references. But if you did want to do gRPC directly, then where we showed our contracts before had absolutely nothing external on them, you would then need to put all your gRPC information on it or generate the types from Proto. And then in the binding, you would just define normal gRPC stuff, and you'd have to do the gRPC conversion within the channel and the endpoint.
Right, unless you had some other way of essentially. I mean, I know that there's some gRPC library, gRPC centric libraries which allow you to program against interfaces. Presumably, if you incorporated that into your channel and endpoint classes, you'd be able to you'd basically be able to do gRPC over an interface.
Yeah, but at that point, you're reinventing some of the dispatching things, I think. That already
Yes.
a lot of those already do that, and so if you're going down that route, you probably wouldn't want to do this. If you're interacting with another service that happens to be over a gRPC that's configured by someone else, then you probably just put the specifics of that within the access component that's responsible to talking to that one thing, because this isn't designed to be something that is ubiquitous across different organizations and across different systems. This is just designed as a way for hosting your system. So whatever you're building will talk to itself using however you set up SoEx, but then if you have to talk to some sort of third party who wants something done in a specific way, then I would recommend just wrapping that in your access component and not trying to make it part of the SoEx configuration.
Yeah, I guess I was just thinking, if I wanted to make the call over HTTP, but I didn't want to sacrifice the performance, if I could leverage gRPC in some way, and then do that, I could probably do it. Although that said, when HTTP 3 comes out, maybe that'll be less of an issue at that stage. So, yeah. Okay.
But then if you're just doing it purely by looking at gRPC, you then have to manage the addresses and everything yourself, at which point I would personally not implement that. I would go for using something like NATS, or carry on and do that implementation that I did on top of Dapper and get that ported across, because then basically
exactly.
the client channel here would just wrap the Dapper client.
Be simple to do that, I suppose, wouldn't it?
And then Dapper itself already uses gRPC, and then when it gets invoked the other side, the endpoint would take the gRPC message, and then it would invoke the endpoint pipeline that we've already got. And so I'd leverage the platform that already exists. So where we're doing the binding and stuff, I'm tending not to look at specific protocols, but look at sitting on top of NATS, or sitting on top of Dapper, or sitting on top of some other technology that already handles your addressing and discovery. So is it in here, there's nothing to do with addressing, there's nothing to do with discovery, but there's lots of tools out there that fit with this client and endpoint model that you can just with a tiny bit of wrapping around them to create a transport for it, leverage whatever discovery or security or discoverability that you want to handle.
That makes sense. Out of interest, so you have topologies under the hood which enforce convention. Could you define your own topology? Like, say, for example, you wanted to include a concept called repository factory or something, as well as an access layer. Could you do that?
As in just name it whatever you want, then yes.
Or even add an extra layer, add an extra layer or an extra type into the topology?
Not really for modifying the topology itself. It's just tied around having components host proxies and endpoints. But in terms of the naming of what you put in it, it doesn't have to follow the method convention. It doesn't have to be a manager engine or access. It can be called whatever you want.
Okay, so it doesn't care what you call it as long as you follow the rules about which things can call which other things.
Yeah.
Okay, great.
So as long as you say that you've got an implementation and you've got an endpoint, and then somewhere else you define a client somewhere, and so it knows how to get a proxy to the endpoint. As long as you define those things, you can call your classes and your interfaces anything you like. So within SoEx itself, it doesn't care about what the specific conventions are, but that's why the method conventions library sits in between everything, so that you can have something pre-built for managers, engines, and accesses. If you wanted to pre-build a convention for something else, that's very easy to do. You just copy the example from the method one and do that. So it's not designed. It's not tied to any specific naming methodology in terms of the names of the components and services themselves.
That's excellent. I suppose my last question really is, you've done a ton of this. There's a ton of plumbing that's built for you, but what if I were building a system myself using SoEx? What plumbing do I have to? What does my IFX typically look like? What plumbing do I have to build on top of SoEx, but still have to build myself?
So if you wanted to start by building a system in the first place, you don't have to do anything extra from the very first step. You can implement the from the template. So like in that tutorial, it gives you how to create the solution in the first place, and that pulls down a template with everything that we've been looking at. And then what you do is you then dig in and go, okay, I want to use a different logging framework. I want to send it to a different endpoint for a different logging actual service. So you could swap out Serilog to Log4net or to New Relic or Datadog. So you need to swap that out, and then you can change the endpoint names for where it actually sends your data and add any credentials that you need for that. And then if you wanted to use some sort of transport that I haven't already implemented, that's when you then go and implement a transport by copying one of the ones that already exist. You don't even have to host it anywhere. You can just reference it when you're setting up your topology. And so as long as that .NET reference exists, it will pull it in and it will work.
Mm-hmm. So what have you got in the IFX in your example there then?
Okay. So in here we've got IFX for the client. So this is just the client builder to say that we've got something for basically making test clients. So normally for something in production, we wouldn't go into this level here. You'd do that, but this just gives us something simpler without having to worry about ASP.NET Core and doing HTTP requests and things. We've got how we want to do conventions. So these are our keywords for the names of our services. So if you wanted to do something else, you can choose to do that. Here's we've got how I've chosen to scan. So you could choose to not scan. You could hard code everything. You could also maybe do something with source generation here to get faster startup time without having to do the reflection scanning. And then this is where I've gone and reflected across all the types, and then I use that system builder that was from the method conventions folder.
Right. Okay. So this is very much a project specific implementation detail here. Okay.
And then for hosting the component, this is where we've gone, and it's very similar to that other part. It combines that scanning. It combines how you want to filter things in or out, which binding you want to register things for. So you could, if all you wanted to do here was change the binding, you could literally copy paste what's in here, and just down here after a bit of renaming, just stick in a different binding.
Okay, so boilerplate effectively at this stage.
Yeah,
okay.
Except it's rather than you having to create any boilerplate, it already exists in the template. It's there. If you're wanting to use something other than named pipe here, just right-click, refactor, rename. So you don't actually have to even copy-paste it. You just rename it to match what you're going to put inside it. Come down here, swap them out. The reason for the demo that I've left it called name pipe rather than being more abstract is because that would be even more confusing. So we've got it doing by hosting in proc, hosting as subsystem. We've got the proxy here. So the idea here being, even though this is a lightweight bit here, this means that all your stuff above only has reference. So in your components up here, your managing access, there are no direct references to SoEx. Everything is a reference into your IFX. And so if you wanted to make your own entire framework, all you have to do is swap it out here in this IFX, and you can create a new implementation that didn't use SoEx, but used the proxy and interface model. And then service is just a helper for the context. In my own implementations for services that I actually use for production, I do sometimes have something extra in here, something then or maybe for specific to the accesses. But anything that is a cross-cutting concern across the components, can come into the service part. But again, this means that you can get the context information out of SoEx without taking a direct SoEx reference in your code.
That makes sense. Okay, there's one thing I've just thought of actually, which if it's not too much trouble to ask at this stage. So the serializer in the transports, does that serialize just the payload, or does it serialize things like, because you're passing context, like you mentioned there, you're passing that over the wire too. Where does that context get added to? Is that part of the payload, or is it part of the header? How does that work?
So let's come across here, and we'll go look in. So we've got an invocation request, and so we pass along the activity ID, we pass along the type of the expected result, the method name, the argument, and the ambient context.
Right. Okay. So you're not utilizing headers or anything. You're just passing it as a predefined payload.
Yeah. So
okay.
we basic ambient context would be comparable to saying headers. If we were an assistant that had headers, but rather than needing every single endpoint and channel to map headers into context and back again,
yeah,
just wrap it in a
guarantee because there's no guarantee you'll even have headers with some obscure protocol or something. Yeah.
And some of them, they allow you headers but with specific rules and things. And so to get around that, what goes across the message body and gets serialized, this gets serialized by whatever serializer you have. So the arguments get set here. The ambient context is first serialized. So ambient context actually gets serialized twice. It gets serialized to be put into here so that we don't have to care what it looks like, and then it gets serialized again as part of the whole request. And then on the way back, you just get the response and the context.
Right. Fantastic. Great stuff. I think I'm out of questions, but if there's anything else you think I should know as a first timer,
no, I think that's a good start there. A reminder for anyone who's got lost on the way, we've got a main repo with everything, and a bit of a step-by-step tutorial that goes into everything. There is still gaps, massive gaps in the documentation. So if anyone wants a specific bit explained, just send me a message and I can do that.
That's tremendous, Blair. I really appreciate this. This has been really great. Thank you.
All right. Thanks for your help running through it.
My pleasure. Absolute pleasure. That was terrific.